It's an all-new standalone headset that doesn't require you to snap in a phone or attach a cable. We're calling it Oculus Go. And Oculus Go is the most accessible VR experience ever. It's an all-in-one headset. It's great for playing games, for watching movies, and for hanging out with friends. And the price is only $199. You've heard me talk about Project Santa Cruz. And today, we have some news for you. I am excited to announce Oculus Quest. It is shipping in the spring, and it is going to cost $399. We are shipping two new products. Oculus Rift S, which improves on the original Rift, a higher resolution display, better optics, inside-out tracking. And of course, we're launching Oculus Quest, the all-in-one headset that we've all been waiting for with no cables and full freedom of movement. So, these are a real step forward. Rift S is the most powerful VR headset that you can buy. And Quest just blows people away because it's the first time that you can just walk around a VR space and fully interact with the people in it. So I'm excited to announce that we're opening pre-orders for both of them today. They're each going to be $399. They're going to start shipping within a month on May 21st.
Oculus Quest 2. Quest 2 has our highest resolution display ever with 50% more pixels. It's more powerful with a custom Qualcomm Snapdragon XR2 processor and 6 gigs of memory. It weighs 10% less than the original Quest and has a new soft strap, so it's even easier to carry around. It has new touch controllers that are more ergonomic and have battery life improvements. It is shipping on October 13th, and we are opening pre-orders today. And it starts at just $299. The team has done an incredible job, and I am really proud of what we've built here. Quest 2 is lighter, faster, and has a better display than the first generation, and it's $100 more affordable. It is fully wireless, and it has hands down the best content library of any VR system out there. Now, there are a bunch of improvements that we have made to the hardware. We've been working on this with Qualcomm for years, and Quest 2 is the first major consumer device that runs on the Snapdragon XR2 platform. It's fully customized for VR and AR with support for multiple cameras and technology like fixed foveated rendering. And the end result is a more immersive experience with crisper graphics, more dynamic environments, and ultimately, just a more realistic feeling of presence.
Next year, we are releasing a new product that will push the boundaries of VR even further. We've codenamed it Project Cambria.
So this isn't the next Quest. It's going to be compatible with Quest, but Cambria will be a completely new, advanced, and high-end product, and it'll be at the higher end of the price spectrum, too. Our plan here is to keep building out this product line to release our most advanced technology before we can hit the price points that we target with Quest. All right, so let's talk about some of the new advances here.
Yeah, sure. There's a ton of new tech going into Cambria. For example, your avatar will be able to make natural eye contact and reflect your facial expressions in real time. This way, people you're interacting with will have a real sense of how you're actually feeling. It does mean building more sensors into a form factor that's comfortable to wear for a while. And because we want VR to be for everyone, we also have to make sure avatars represent a diverse set of human facial features and skin tones, as well as paying attention to things like glasses and beards that might get in the way of some of the sensors.
So that's going to be a big step forward for social presence, and I'm really glad that we're focused on making it inclusive from the start.
We came up with a way to change the focal depth to match where you're looking by moving the lenses dynamically, kind of like how autofocus would work on a camera. And this is known in the industry as varifocal technology. So in 2017, the team built a prototype version of a Rift that had mechanical varifocal displays that could deliver a proper depth of focus. And it used eye tracking to tell where you were looking, and real-time distortion correction to compensate for the magnification effects of moving the lenses and any rendered blur, so that way only the things that you were trying to look at were in focus, just like if you were trying to look at something close by in the physical world.
Right. And then once they had that prototype, they ran a study to see if people actually preferred this varifocal technology. And on one day, they would enable varifocal fully on the prototype, and on the other, they would just operate it in fixed focus mode. And what they found was that the majority of participants preferred varifocal over fixed focus VR. They were more comfortable in every respect. They experienced less fatigue and blurry vision. They were able to identify small objects better. They had an easier time reading text, and they reacted to their visual environment more quickly.
So here's the prototype, and once we had this feedback, the team put all their energy into getting the size and weight down and expanding the field of view. And the series of prototypes that they built, which we call Half Dome, ended up using fully electronic varifocal based on liquid crystal lenses, which are much smaller. And even with all this progress, there's still a lot more work to do to get the performance of the varifocal hardware fully optimized.
So the key metric for HDR is nits, or how bright the display is. And research has shown that the preferred number for peak brightness on a TV is 10,000 nits. And the TV industry has made progress in introducing HDR displays that move in that direction, going from a few hundred nits to a peak of a few thousand today. But in VR, the maximum nit level right now is about 100 on Quest 2. And getting beyond that with a form factor that's wearable is a big challenge.
Yeah, so we're going to need to get to significantly higher brightness levels than what we refer to as HDR on traditional screens today. And then, of course, the challenge is we need to do that in something that is battery-powered and comfortable to wear. So, to try to figure out the best path forward, our display systems research team built this prototype, or I guess this is a part of the prototype, that basically puts an incredibly bright lamp behind the LCD panels. And this one's pretty heavy, so we have these handles so you can hold it like that. But as far as we know, this is the first HDR VR system, and internally we call it Starburst. It's, to be clear, wildly impractical in this first generation for anything that you'd actually ship in a product, but we're using it to test and for further studies so we can get a sense of what the experience feels like. And the goal of all this work is to identify which technical paths are going to allow us to meaningfully improve in ways that start to approach the visual realism that we need. We're also looking at some further out solutions that could enable us to take big leaps forward. And at the same time, we're working on how to package all these different technologies into smaller, lighter, and ultimately affordable headsets. So today, we have two more things to show you that are going in exactly that direction, trying to take everything that we've learned from our research and trying to bring them together into a compact form factor that could plausibly get us to visual realism. These are all still prototypes, but they represent pretty meaningful steps towards technology that could one day deliver breakthrough products. So the first one up is an experimental device that brings together some of the latest optics research into a fully functional headset that is unlike anything that exists today. This one we call HoloCake 2. It is the thinnest and lightest VR headset that we've ever built, and it can run any existing PC VR title. In most VR headsets, the lenses are pretty thick, and they have to be positioned a few inches from the display so they can properly focus and direct light directly into your eyes. And this is what gives headsets that look where they're pretty front heavy. But HoloCake 2 introduces two new technologies to get around this. The first one is that instead of sending light through a lens, we send it through a holograph of a lens. And holographs they're basically recordings of what happens when light hits something. So, just like a holograph is much flatter than the thing itself, holographic optics are much flatter than the lenses that they model. But they affect incoming light in pretty much the same way. So it's a pretty neat hack. The second new technology is it uses polarized reflection to reduce the effective distance between the display and the eye. So instead of going from the panel through a lens and then into the eye, light is polarized, so it can be bounced back and forth between reflective surfaces multiple times. And that means that it can travel the same total distance, but in a much more compact package. So the result is this thinner and lighter prototype than any other configuration. But as with anything, when you're building these integrated systems, there are trade-offs and there's a catch. So Michael, you want to take us through that?
Yeah, that catch involves getting the right light source. So HoloCake requires specialized lasers, and that's pretty different from the LEDs that are used in today's VR headsets. And lasers aren't that exotic these days, but they're really not found in a lot of consumer products at the performance, size, and price that you need for consumer VR headsets. So we'll need to do a lot of engineering to achieve a consumer viable laser that meets our specs, that's safe, low cost, and efficient, and that can fit in a slim VR headset. As of today, the jury is still out on finding a suitable laser source, but if that proves tractable, there will be a clear path to sunglasses-like VR displays.
I'm quite optimistic about the direction that all this is heading. A big part of your job, of course, is trying to imagine, all the future technology that we're going to need to solve, and the state of what these technologies will need to be in, 5 to 10 years from now for the multiple generations out of devices that we're building. And I think you have one other design that you wanted to show today. Is that right?
Yep, we have one more design. So ultimately, the goal, obviously, is to bring together all of the technologies we've talked about, integrating all the visual elements needed to pass the Turing test into a lightweight, compact, power-efficient form factor. And we're designing the Mirror Lake prototype right now to take a big step in that direction. So Mirror Lake is a concept design with a ski goggles-like form factor that takes the HoloCake 2 architecture and then adds in nearly all of the advanced visual technologies that we've been incubating over the past 7 years, including varifocal and eye tracking. It shows what a complete next-gen display system could look like. So the key here is that thanks to holography, everything is thin and flat. The varifocal technology is flat, and so are all the holographic films used for HoloCake, as well as prescription correction and eye tracking. And so it's easy to keep adding thin, flat technologies. This means that the end product can pack more functionality into a smaller package than anything that exists today. Now, the Mirror Lake concept is promising, but right now it's only a concept with no fully functional headset yet built to conclusively prove out the architecture. But if it does pan out, it will be a game changer for the VR visual experience.